This is the number 3 final review. It's going to be a portion of chapter 4. You are going to be asked in the first set of problems to classify the triangle using the converse of the Pythagorean theorem. And as you can see to the right, the converse of the Pythagorean theorem, and again this is put into my own words, if, so it's deductive reasoning, if c squared, that's the longest side squared, equals a squared plus b squared, those are the two shorter sides, then it is a right triangle. And if it's a right triangle, then C would be the hypotenuse and A and B would be the legs. However, we can also deduce certain other things from this converse of the Pythagorean theorem. And that is that if A squared plus B squared, the two shorter sides squared, are greater than C squared, the longest side squared, it's an acute triangle. We already know about a right triangle. If A squared plus B squared equals C squared, it's right. And then finally, if a squared plus b squared is less than c squared, the two shorter sides squared are less than the longest side squared, then it will be an obtuse triangle. You're going to need to know those patterns. You're going to need to know those patterns. They won't be given to you. Okay, so we have a triangle with the sides of 13, 15, 22. And we're looking for what kind of triangle it is. So a triangle with sides of 13, 15, 22 is what type of triangle? I also want to bring up this because this is going to come later in the lesson. We know it's a triangle because if you take and add up all of the sides, they should always be greater than the third side. So we start with 13 plus 15, that's greater than 22. Then we go 15 plus 22, well that's greater than 13. And finally we go 22 plus 13, which is greater than 15. If all three of those things are true, then it is a triangle. All right, now back to the converse of the Pythagorean theorem. So we've got 13 squared shorter side, 15 squared shorter side is what compared to the longest side, which is 22 squared. 13 squared is 169, 15 squared is 225, 22 squared is 484. Please use your calculator for the larger ones. And then 169 and 225 is 394, which is less than 484, which means that looking at the pattern up here, a squared plus b squared is less than c squared. It's going to be an obtuse triangle. Now, I'm going to have you write down a couple of problems, and you're going to do them, then you'll turn the recording back on to check your answers. All right, number 1 is the segment lengths 6, 8, and 10. We already know these are triangles, but let me show you how you can prove that, because this will come into play later in the lesson. If you take all sides, two of the sides, and add them, and they're greater than the third side, it will be a triangle. 6 plus 8 is 10. 8 plus 10, 6 plus 8 is greater than 10. 8 plus 10 is greater than 6. And 10 plus 6 is greater than 8. Since all three of those are true, then it's going to be a triangle. Down here in number 2, the segment lengths are 11, 14, and 16. We know for certain this is a triangle because 11 plus 14 is greater than 16. 14 plus 16 is greater than 11. And then finally, 16 plus 11 is greater than 14. So if all those things are true, then we know it's going to be a triangle. We knew that already, but it's just good practice for when we get to the later part of the lesson. Once you've solved these, please turn it back on. Make sure you show your work. You are going to be turning these problems into me. Okay, so 6, 8, and 10. You take the shorter side, 6 squared plus 8 squared, and you determine how it compares to the longest side, 10 squared. So you get 36 plus 64 is what compared to 100. 36 plus 64 is 100, so 100 equals 100, meaning it's equal. So it is a right triangle. That is the actual converse of the Pythagorean theorem. On number 2, you take the two shorter sides, 11 and 14, and square them and see how they compare to the longest side squared. So 11 squared plus 14 squared equals 16 squared. 11 squared is 121. 14 squared is 196. How does it compare to 256? 121 and 196 is 317, which is greater than 256. When the two shorter sides squared are greater than the longest side squared, it is an acute triangle. Okay, moving on to the next part of the lesson. Okay, we want to order the angles now from the largest to smallest. We're going to do that using the theorem 4.10, which states an angle opposite the longest side will be the largest. So if we look at the sides, we see that we want to go largest to smallest, so that we see the biggest side is 10, so the angle opposite that is B. So angle B will be the largest. And then we go to the next size side, which is 7. The angle opposite is A, so angle A. And then finally, we don't even need to do this, but we can look and see the smallest side is 4, the angle opposite is angle C. So it's angle B, angle A, and angle C from largest to smallest. Now, the other theorem is 4.11, which is kind of the converse of the one we just did, the opposite of the one we just did. This time we're going to order the sides from shortest to longest using that theorem. A side opposite the largest angle is the longest. So a side opposite the smallest angle would be the smallest. So now we're going to go short, would be the shortest. So we're going to go shortest to longest. So we look at the smallest angle, that's 33 degrees, which means NM, segment NM, would be the smallest one. Then we go to the next one, the 65 degrees is the next size angle. So we go directly across. NO would be the next size segment. And then the longest segment would be across from the 82 degrees, which would be MO. So in order from shortest to longest, it's segment NM, segment NO, and then segment MO. I'd like you to do the next 2 problems. And then turn the recording back on, check your answer. Okay, number 3, you have triangle HIJ, and you're ordering the sides from longest to shortest. And then on number 4, you have triangle QPR, and you're going to be ordering the angles from smallest to largest. When you're finished, turn the recording back on and check your work. Okay, number 3, we're going longest to shortest. 100 degrees is the longest, or is the biggest angle, so HJ is the longest side. 45 degrees is the next one in size, so IJ is the second longest side. The third longest side, or the shortest side, would be IH, because it's across from the angle J, which is 35 degrees. Number 4, this time we're ordering the angles from smallest to largest. We're going to go to the smallest angle, which is the smallest side, which is 19. So angle P is the smallest. The next sized side is 20 PQ, so angle R, and then the largest side is 21, so angle Q is the largest angle. It's opposite. Okay, next we're going to work on determining if segments will in fact can be used to create a triangle, and we'll use the theorem 4.12, the triangle inequality theorem. Okay, in this next section we want to figure out whether the segments that are given will form a triangle. So will the segments form a triangle? That's the question. We have to use theorem 4.12, which is the triangle inequality theorem, and basically, this is in my own words, what it says is that to be a triangle, the sum of 2 sides, that's any 2 sides, of a triangle will always be greater than the third side. Now, in the book, they'll just give you segment values. I think it's helpful to put them on a triangle. No, this is not to scale because some of these will not form triangles, and here's what I do. 6 plus 7 has to be greater than 15. Well, it's not, because 6 plus 7 is 13, which is not greater than 15. So, right away, we can say this is not a triangle. Okay, or will not, guess we should say it a little bit differently. Cannot be a triangle. So it cannot be a triangle. So given those segments, it cannot be a triangle. Okay, let's try another one. And you've done several up in the earlier parts of this assignment. I went through that with you. Let's go ahead and do the segments 4, 9, and 11. Again, I'm going to just draw a triangle to give me a visual. It's not to scale. It may or may not be a triangle. So if we have 4, 9, and 11, and I would simply go 4 plus 9. Let's do this in red. 4 plus 9 is greater than 11, because that's 13 is greater than 11. Then I'm going to come, so I went first this way, then I went this way. It's forming a big circle. 9 plus 11 has got to be greater than 4. Well, it is. 9 plus 11 is 20, which is greater than 4. And then I'm going to go 11 plus 4. 11 plus 4, which is 15, and that is greater than 9. Since all of those work out, that each of the sum of two sides is greater than that third side, then yes, this can form a triangle. All right, so you're going to be given 2 more problems, and you're going to make a determination as to whether or not it can or cannot form a triangle. Okay, number 5 is the segment 6, 7, and 13. And number 6 is the segments 6, 9, and 13. So I prefer that you actually have a visual to help you, but it's not completely necessary. But you do have to have at least the work showing what you did. So there's a tiny bit of work. I prefer a visual, but you don't have to have it. Once you're done, go ahead and shut off the recording, or turn on the recording and check your answer. Okay, you have 6, 7, and 13. I'm just going to label it 6, 7, 13. And so I'm going to start with going around. And 6 plus 7 has to be greater than 13. Well, it's not, because 6 plus 7 is actually equal to 13. So no, cannot be a triangle. Okay, let's go to the next one. As soon as it's not right, then you can't be a triangle. We've got 6, 9, 13. Okay, we're going around in a big circle. 6 plus 9 has to be greater than 13. Well, 15 is greater than 13. 9 plus 13 has to be greater than 6. It is. 9 plus 13 is 22, which is greater than 6. And then lastly, 13 plus 6 is greater than 9. Yes, that's true. 13 and 6 is 19, which is greater than 9. If all 3 of these things are true, then you're going to answer yes. This can be a triangle. Okay, that is the end of final review number 3. Make sure that it's on a piece of paper, 1 through 6, because you're going to be turning it into me during class. I'll be collecting it.